allow one or more than one processes to consume records from topic in parallel. It means with the help of consumer group, we will run multiple consumers so that we can utilize the parallelizations concept like multi-threaded concept of Java. If one process stops, even though we can read the data from the Kafka topics, right? So this is very recommended. We must use consumer in the consumer group, and we must run this consumer in the group on multiple machines. If one machine crash, then even though we can read the data from the Kafka server, because our other consumer is running on the other machines, right? So this process can either be running on the same machine or they can be distributed over many machines to provide scalability and fault tolerance for processing. To run all the consumer in a group, we must set the group ID, same group ID, right? Topic partition is assigned to exactly one consumer in the group. Because in the group we have a multiple consumer, that the topic partition will be assigned to a particular consumer in a group. Two consumers never will read the data from the same topic partitions, right? So there is many partition. We can do 1 2 3 up to our choice how many partition we want. While creating the topic, we can specify that time, right? For example, if there is a topic with 4 partitions and there is a consumer group with 2 processes, so each process would consume from 2 partitions, right? Membership in a consumer group is maintained dynamically. Automatically it will maintain. It is transparent to the user, right? So if a process fails, the partition which was assigned to it will be reassigned to the other consumers in the same group, right? Similarly, if a new consumer joins the group, then the partition will be moved from existing consumers who were assigned more than one partition to the new one. This is known as rebalancing the group, and it happens automatically and it is transparent to the user. User no need to worry about that, right? So you can see here, let's say we have a producer applications here, multiple application which is producing the record in the sales topic, and the sales topic have like 5 partitions. It's a mistake actually, partition 0 1 2 3, and this will be 4. It's a typo mistake, typo. And the Kafka broker, inside Kafka broker we will have topics, and on the other side we have a consumer applications. And see here, we have a consumer 0 1 2 3 4 5 consumer in the consumer group, and the maximum consumer can be added into the consumer group is is up to you. You can add 4 5 6 7 8 10, up to you, but no point if you have a 5 partitions, so that only 5 consumer can run at a time, because one consumer will read the data from the one partition. In this case, if we have a 6 consumer, then the last consumer will be idle because there is no other partition, only 5 partition, only the 5 consumer will read from each of the partitions, right? So it will provide scalability. We can distribute on the multiple machine. We can run every consumer on the different machine, and it will also provide, because of distributions, it will provide the fault tolerance. If one machine fails, even though other consumer will read the data, right? So we will see, like, what if any consumer crashes, right? Let's say the consumer 4 crash, what will happen, right? Because the consumer 4 was reading the data from partitions 5 here, right? So what will happen? So group reassignment happens automatically. It means rebalance. If the consumer 4 is crashed, then this will partition will assign to any of the consumer. In this case, I've shown you here that this assigned to the consumer 3, right? So, and this will happen automatically. It is transparent to the user, right? What if a new consumer join the consumer group, right? Let's say the consumer 4 join, right? So reassignment happens, rebalance happens, and it will assign the partition If any previous consumer is consuming the records from more than one partition, so it will reassign that partition to the new consumer, right? So what if number of consumers in a consumer group is more than the number of partition of a topic? In this example, I said there is a 5 partition and there is a 6 consumer. So the consumer 5 will sit idle, right? Already I said to you, because one consumer will read the data from the one partitions. The consumer cannot share the partitions, right? So every consumer will read from its own partition. So because we have 5 partitions only, so only 5 consumer will read at a time, and the 6th consumer will sit idle. If any one of the consumer will crash, so maybe it will get consumer 5 will get the chance, right? So let's see in practical the consumer group. So in the previous video we have created here the consumer applications, right? So we have a topic foo and we are consuming records, and we have created the jar as well. We have created the jar, a consumer jar to consume the data, right? And this jar is running on the terminal. Let's see, I run java-jar consumer demo.1.jar, right? And now what I will do is we will produce the data, right? So here I'm going to produce the data. So I will use the Kafka console producer tool here. So here I'm passing property, like I will pass here key and the separator is semicolon, right? And the key, let's say I pass here 20. Hi, and you can see I'm getting the data here, right? There's only one consumer, right? And 21. Hello. All the data is being received by one consumer, right? Now I will run the another consumer, right? Let's see what's happened. So here I'm running the other consumer, right? And group ID is the same because I mentioned here, right, in the applications group ID is the test, right? So I can run multiple instances. So one consumer jar I'm running here, consumer applications, another consumer I'm running here. So now we have two consumer, right? Consumer 1 and the consumer 2. So let's what happen. So sending data, see the key and value pair. So you can see here the consumer 1 read 21 and see here consumer 2 read 22, 23, 24, 25, right? So both consumer is sharing the data, right? Reading the data, right? 27, yeah, 28, right? You can see this is also reading and this is we are reading here, right? Let's say I run another instances of the group consumer, right? So java-jar consumer. Now there is a 3 instance, right? This is the 1, this is the 2, this is the 3, third, right? So we are running. Now let's see what's happened. 29 chai j k, right? So you can see here, so k is read by the first consumer, here j is read by the second consumer, and I is read by third consumer, right? Let's try again. L, you can pass any data, right? So you can see you can see here k is read by first consumer. You can see mn read by the second consumer, and here L is read by third consumer. Okay, now we have a 3 consumer, right? What if I will run another consumer. Jar consumer. Now let's try. Right, but you can see here this I have produced OPQR. So you can see here OP is read by the first consumer, right? QR is read by the second consumer, right? And you can see here the fourth consumer did not read, and maybe the third will also read, not a problem. 35 36, yes, you can see, right? But you can see this that the fourth consumer is not reading any data because topic has only three partitions. It means the maximum three consumer will run at a time and consume the data at a time from the topics, but the fourth one will not get any data. It will sit idle, as I said to you here, right? So because the number of consumer in a group is more than the number of partitions in a table. So in this how to check the number of partitions, that how many partitions we have in the topic, right? So we have a Kafka topics tools hyphen hyphen describe, and then we have here hyphen hyphen zookeeper, localhost. What is the port number? 2181 2181 and topic foo, right? So it will tell you the detail of the, you can see here the partition 0 1 and 2. That's why the fourth consumer of the group is not getting any data, because three partitions, right? And we are getting the data from the consumer 1, consumer 2 and the consumer 3 applications, because the group ID is the same as test. I created the jar and I'm running the same jar on the multiple terminals, different terminals. So there is a four processes running and getting the data from the Kafka brokers, right? So here the first consumer process is getting the data, the second one getting the data, the third process is getting the data, but fourth one is not getting the data, right? I'm running but it is not getting the data. Let's say terminate the first one. Now I'm terminating the first one, right? I close. Now we have the second, third and fourth. Let's see now the fourth one is getting data or not, right? So here let's produce a all is getting by the second. Let's try. Forty 21. Now you can see the fourth consumer is getting the data from the Kafka broker, right? Because at a time only the three, because the three partitions we have, the maximum three consumer can run in a group. Because I have terminated the first consumer, now we have 1, 2 and 3 consumer. Now you can see here this consumer is getting the data, right? Because the first already I terminated, right? So this is how the consumer group works. So it is good idea to run your multiple consumer process in a group on multiple machines, so that we can get the advantage of the scalability, fault tolerance, right? So we can run this jar on the multiple machines in the network, so that one machine crash, even though our consumer will read the data from the Kafka brokers. Hope consumer group concept is clear now. So thank you very much. We'll see you some other concept in the coming videos. Thank you very much.